This is the second lesson in Chapter 9. It's about theoretical and experimental probability, and there is an activity that accompanies this lesson in your note packet. So if you have access to a number cube or a die, that would be the best thing to do before watching this video to complete that activity. Okay? So assuming that you've completed the activity, let's go over some vocab. First vocab word is the word theoretical probability. Theoretical probability is when we find probability by examining the conditions of the problem. This is what should happen in a probability experiment. So if I have a die and I look at all 6 sides of the die and I see that one of those sides is a 2, then I can determine that the theoretical probability of rolling a 2 is 1 out of 6. I'm not actually doing anything or rolling any dice. Okay? Experimental probability is different. Experimental probability is when we take the time to carry out an experiment or somebody else carries out an experiment for us, and we use the data from that experiment to find our probabilities. So this is probability based on what did happen in the past. Okay, so experimental probability, we have data from an experiment. Theoretical probability is when we look at the conditions of the problem and we make a prediction of what should be happening. So here's an example for us to look at. This is from your notes. Alice flipped a coin 45 times. She recorded her data. So it looks like she recorded 21 heads, 24 tails. If we add them up, we get 45. What is the experimental probability of getting tails? Well, we know that she flipped the coin 45 total times, so that's our denominator, 45. And the numerator is going to be the number of tails she got, 24. Now we can simplify that, divide the numerator and denominator by 3, and we get 8/15. So that would be the experimental probability of getting tails. Experimental probability is when we use the data from an experiment. Okay? Theoretical probability is the exact same probability that you've been doing for years and years and years. This is when we don't carry out an experiment. We just look at the coin and we say, okay, a coin has 2 sides. Of those 2 sides, one of the sides is tails. So the probability of flipping tails, the theoretical probability of flipping a coin and getting tails is 1/2. So that's the big difference between experimental and theoretical. Experimental has to have data that has been collected from an experiment. Theoretical is when we just take the time to look at the item, the coin, the die, the conditions of the problem, and we make predictions based on what we think should be happening. The next problem is the one you're going to do. I will help you get started a little bit. It says Jack has a very messy sock drawer. In his drawer, he has 6 black socks, 14 white socks, and 4 gray socks. He reaches in his drawer and picks a random sock. He records the color of the sock and puts it back in the drawer. He records the data below. Which color has an experimental probability closest to its theoretical? So, first of all, here's his data. He picked black 19 times, white 22 times, gray 9 times. So this is going to be used for our experimental probabilities only. Up here, the 6 black socks, 14 white socks, and 4 gray socks, that would be the setup or the conditions of the problem. So we would use those numbers to help us find the theoretical probability. So we will do black together, okay? Black, let's talk about theoretical first. 6 black socks, 14 white socks, 4 gray socks. Before I can do any probabilities here, I need to know the total number of socks in the drawer. So if I add them together, 6 plus 14 is 20, plus another 4 is 24. So the total is 24. Of those 24 socks, I know that there are 6 black socks. So my theoretical probability is 6/24. Now I want to do the experimental probability. Experimental probability uses this information down here, the data that's collected from the experiment. So black got drawn 19 times, 22 times for white, and gray 9 times. So in order for me to figure out this probability, I have to know how many times he picked socks in all. So if I do a quick addition problem, 19 plus 22 is 41. 41 plus 9 is 50. So we know that the total number of picks is 50. So my denominator for the experimental probability of getting a black sock is 50 because there were 50 picks in all, and he got a black sock 19 times. So the question asks here, which color has an experimental probability closest to its theoretical probability? Fractions, if we want to compare fractions, we can either find a common denominator or we can change them both to decimals. I think it's easiest to change these both to decimals because that makes it easier to compare our two numbers without having to find that common denominator. So to do that, we do a division problem, 6 divided by 24. I'm going to speed things up here and tell you that the decimal for the theoretical probability is 0.25. It's 25 hundredths. Experimental 19 divided by 50 is 0.38 or 38 hundredths. So I did the first step for you. If I were you, I would set up this exact same table in your notes to help you with number 2. I would do the theoretical probabilities next, the experimental probabilities after that, and then find the decimals and see which two are closest. Okay, finish up this problem and we'll talk about it in class.